Hi everyone. So today we'll be learning about a special type of logarithm which is known as natural logarithms. Okay, natural logarithms or natural logs. Okay, so today we'll be learning about natural logarithms. So what are natural logarithms? It is just another type of logarithm with a special base of e. Okay, so whenever you use logs, now we have used logs with different bases, with base of 10, with any other number as base. Okay, so now the special base for which this log is used, it is log of x to the base of e. Now people will ask, what is e? So e is just defined as an irrational number. E is just defined as an irrational number, and the value of e is approximately equals to 2.718. Okay, so what is e? E is just an irrational number, okay, which is used in logs. So now logs with the base of e are known as natural logs. Okay, so e is an irrational number whose value is approximately equal to 2.718, and logs to the base of e are known as natural logs. Okay, so suppose we have y is equals to e to the power of x, or you can write e to the power x is equals to y. Okay, so if we'll write it in log form, so it will be x is equals to log of y to the base of e. Okay, so this form, this thing which is at the right hand side, when any number is to the base of e, then we write it as ln. Okay, so this can be written as ln y. Okay, so any argument with the base of e, any argument with the base of e is written as ln of that argument. So you can write log of argument to the base of e is equals to ln. Ln is the symbol which we automatically use when we know that the base is e. So this will be equal to ln of argument. Okay, so this is the thing that you just have to remember. And all the laws of logarithms which we had studied earlier, they'll just apply to this natural log also. So whatever we have studied, whatever laws that we have studied for logarithms with different bases, that same those same laws will also apply to this logarithm with base e. Okay, so these are known as natural logs or natural logarithms. Okay, so there are some questions asked in your papers on this. They are not very difficult, so this is the method through which you can attempt that. Okay, so now we'll just do another topic. So this was a very small topic, natural logarithms. Now we'll just do another topic and we'll just solve an example of that also. Now our topic is practical applications of exponential equations. Okay, we have studied exponential equations before. Okay, so now we will just study its practical application. Okay, so there are a lot of questions asked in your papers regarding this, so we'll just solve an example. Okay, so it will be more clear to you. So the question is, the temperature T degrees Celsius of a hot drink, T degrees Celsius of a hot drink, T minutes after it is made, T minutes after it is made is given by capital T is equals to 75 into e to the power of minus 0.02 small t plus 20. Okay, so we have the temperature capital T of a hot drink, and small t is the minutes after it is made, so it is given by the equation this. Okay, so we have to find the temperature of drink, find the temperature of drink when it was made, temperature of drink when it was made. Okay, now you have to find the temperature of the drink when it was made. You have this equation of capital T and small t, and capital T is the temperature of a hot drink and T is the time after which it is made. Okay, so you have to find the temperature of drink when it was made. Okay, now how we'll find this, how we'll find this. You have to find the temperature of the drink when it was made. So when it was made, you know that when the drink was made, when T is equals to 0. Okay, when T is equals to 0, the drink was made. So when T is equals to 0, we'll just find the value of capital T. Okay, you just have to find the temperature of the drink when it was made. So when it was made, it was small t is equals to 0. And when we'll put small t is equals to 0 in this equation, then you'll get capital T, which is the temperature of the drink. Okay, so what we'll do, we'll just put small t is equals to 0 in this equation, and we'll just find capital T for the temperature of the drink. So if we'll put small t is equals to 0, what we'll get, 75 e to the power minus 0.02 t is 0 plus 20. So what it will become, t is equals to 75. Now 0 minus 0.02 into 0 is 0. So 75 e to the power 0 plus 20. So t is equals to e to the power 0 is 1. Any number to the power of 0 is 1. So this is 75 plus 20. So this is equals to 95. So the temperature of the drink when it was made, it was 95 degrees Celsius. Okay, so you can find the temperature of the drink when it was made. Okay, now there's a second part to this question. Now we have a second part to this question. We'll just write the equation. The equation is t is equals to 75 into e to the power of minus 0.02 t plus 20. Okay, so the second part is you have to find the temperature of the drink. You have to find the temperature of the drink when t is equals to 6. Now what you will do, you'll just put the value of t is equals to 6 in this equation so that we can find out the temperature of the drink. So t is equals to 75 e to the power of minus 0.02 into 6 plus 20. Okay, so your temperature will approximately come, which will be equal to 86.5 degree Celsius. Okay, so it is very easy. You can find the temperature of the drink by putting the values. Okay, so now we have our third part. The third part is find the value of t. Find the value of small t. Now you have to find the value of small t, which is the time. Okay, when the temperature of the drink capital T is 65. Okay, now you have to find the value of small t, which is time, when temperature is equals to 65. So what we'll do, we'll just put capital T is equals to 65 in this equation. So when t is equals to 65, what will the equation become? 65 is equals to 75 e to the power minus 0.02 t plus 20. Okay, now we'll just scoot this 20 over here. So 65 minus 20 is 45. So 45 is equals to 75 e to the power minus 0.02 t. Okay, now if we'll divide both sides by 75. Okay, if we'll divide both sides by 75, so what we'll get 0.6 is equals to e to the power minus 0.02 t. Okay, now what we'll do, we'll just take ln both sides. Okay, if we'll take ln both sides, ln of 0.6 is equals to, now we'll take ln of this. So when we'll take ln of e to the power minus 0.02 t, so what it will become, it will become directly the exponent, so it will become minus 0.02 t. Okay, so this is how we have just taken ln both sides, so that you can just directly write the exponent over here. Okay, because log ln of e to the power of minus 0.02 t to the base of e is just the exponent. Okay, so what we'll do here, we'll just find the value of t. So the value of t is ln of 0.6 upon minus 0.02. So this value will approximately be equal to 25.5. So we have to give our answers up to three significant figures. So T is equals to 25.5 when the temperature of the drink is 65 degree Celsius. So this is how there are some practical, these are some practical applications of exponential equations. So you are asked these type of questions. So this is the method that you will use to solve this.